Let's code a function that copies one vector into another vector. We've seen this previously as the copy routine. So if I have an m by 1 vector x, we literally just take each entry of x and copy it into the corresponding entry of y. That's represented by this pseudocode. However, when we're thinking about defining functions, remember one of the major ideas that we're kind of leveling up to is what we call production code. So code that we want to include in a library that we might provide as a software package. One thing that's kind of interesting in that process is to define specifications for the type of functionality that we want. So here's a claim. If we look at this core functionality for the copy function, I'm going to impose a bunch of specifications on that. Here is my list. So we're going to call up a function that does a few things. It takes two vectors as input. We're going to call that vectors x and y. Both should be stored in double precision. This is part of our basic linear algebra subprogram level 1. Our focus together is going to be doing it all in double. The vector x must be either a column or a row vector. The vector y should also be a column and a row vector. They should probably have the same size. If I'm going to copy one into the other, maybe I require that they have the same size. I could say that one could be larger than the other, but for now I'm just going to make it easier and just say let them be the same size. We're not going to deal with that other issues. We're going to produce an error vector if either x or y is empty, if either is stored not as doubles, if either is not a vector, or if they have different number of entries. The output should be a copy of the vector x into the vector y, but the dimensions of the output should be identical to those of y. So notice that we do not require in this situation that x and y have the same dimensions. What we're going to do is copy the entries of x into the vector y, but the dimensions of the output are going to match the dimensions of input vector y, not the one that we're copying. This work is going to be an extension of the previous work that we did with the scalar operations. And in fact, one of the things that I love to say is when you've spent a lot of time developing code that you know works, it's super useful to use that code as a starting place. So in this case, we're not going to do a dscale function, double scale function. We're going to do a dcopy function. And literally all I'm going to do is create a copy of the exact file that we've already tested from a previous video to create my new file. The same thing is true when we're looking at the creation of a new function. We always want to make sure that everything that we desire actually is produced in that function. So we're going to use a driver to do that. We'll copy our old driver, and now we'll just go ahead and open those. So what's really nice about this is because we spent so much time on those other functions and we know that they work, we're not starting from scratch. We have a bunch of code that we can reuse and edit. MATLAB is getting upset because my dcopy function doesn't match the name of the function. So here I'm going to call this dcopy, and I'm going to go down and say this is the end of the dcopy function. Up top, of course, there's going to be not alpha and x, but it's going to be x and y. And we're going to rename this dcopy copies a vector x into a vector y. So now that we've changed the name and the description of what the function does, let's go back to the driver. This script file is used to test and debug the dcopy function. Here, I've kind of already designed my specifications for how I want them, so I'm literally just going to copy those over in this location. Here we go. So the dcopy function does a number of things. It takes as inputs two vectors x and y. The vector x can be either a column or row vector. The vector y either a column or row vector. Dcopy produces an error vector if it doesn't have the proper number of inputs. Inputs are empty, blah, blah, blah. The output should be a copy of x, so we'll call the output x out, which kind of gives us a sense, right? X out is going to be our copy. And then the dimensions of the output should be identical to those of input vector y. This script file tests all the conditions to verify. This, of course, script file needs the dcopy function file and also see dcopy since this is the one to test. Today is still October 3rd. I'm doing this. Here I have a bunch of commented code. When I run it, nothing happens because there's nothing in the, other than clearing the workspace and clearing the command window, nothing happens. Okay, so dcopy copies a vector x into a vector y. We've got the driver set up. Let's go ahead and make sure that my documentation is proper. The vector x can be either column or row. If x is a column, we say that x is an m, let's say mx by one vector. If x is a row vector, we say it's a 1 by nx, where m is the number of rows and n is the number of columns. Notice one dimension should be 1 at least. And then the same thing is true. We could also say that the vector y can be either a column or row vector. If y is a column vector, we say that y is an my by 1. If y is a row vector, we say that y is an 1 by ny. Notice that one dimension must be equal to 1. One notable part of this particular function is that the number of entries of y should equal those in x, even if dimensions are different. In other words, you could have a column vector and a row vector, but the number of actual entries should be the same, right? Kind of an interesting question whether or not we want to call the output x out or y out. We know that, let's think about this for a minute. I have to kind of imagine. So the goal of this function is to take x and copy it onto y. So what we're going to do is output a vector y that has the same entry values as x. And so I actually want to revise this. I might call this y out. So that the output vector is basically y, except that all the entries of y have been overridden by x. In other words, let's go ahead and comment what we mean here. So the output y out is a copy of x with identical dimensions as the vector y. If y is a column vector, the output y out is a column vector too. If y is a row vector, then the output y out is a row vector. This is true independent of the dimensions of x, though both must have the same number of entries, which we've kind of specified up there. We don't need this. This is kind of an edit of our previous work. All data should be stored as double precision. Inputs x and y should be in double precision, and then y out should be in double precision. And of course, the syntax that we're going to use is going to be dcopy. Again, all we're doing here is just making sure that one works out to the other. This produces a copies vector x into vector y with inputs. We have array x stored in double precision, can be a store row. We also have a vector y, so let's go ahead and write that up. Array y stored in double precision. This vector determines the size of the output. Can be stored as a column or row vector. Must have the same number of entries. Must have same number of entries as vector x. And I suppose we should probably clarify that also for vector x. So this must have the same number of entries as vector y, just so that readers of this kind of know what we're doing. In this case, we're going to actually change the code. We're going to say that y out, change the documentation, is an array as a copy of x. So y out literally is a copy of x stored in double precision. The output size matches the size of the input y. And it might not match the size of x, right? So if x is a column vector, y is a row vector with an identical number of entries, then y out will also be a row vector. It's just that the individual entries will be those of x when we do it. I'm going to go ahead and say that we're going to wait on the example stuff. We don't have that. Other M files required, I suppose that this is going to be dcopy, so dcopy.m. Subfunctions, there's none. MATLAB files, none. I would definitely say that folks that were reading this would want to check out the dcopy.m function. And to be honest with you, we've already written the dscale.m. And that's probably useful to take a look at, right? Like, because it's related to this. Again, I'm going to go ahead and call out the references that were kind of useful here. And then I pretty much think we're ready to roll. We haven't used y yet. Let's go ahead and comment all of the stuff that we don't need at this moment, because what we're doing is we're just reusing the code but making sure that it works. Let's go to the copy driver, and we're going to do some error checking. So in this case, we don't need a scalar. We actually need two vectors. So let's go ahead and do the 2 input test. So we'll call this y, we'll call this y out, and we'll call this copy. Let's pass 1 input to begin with and see what happens. Notice MATLAB gets angry. I've now tested that that line is working. We already knew that line was working because we're just reusing it. This is the nice thing about making code that works. You can reuse it again in the future, and it's a lot easier than the first time you do it. Let's test if we push in y. What happens? Same thing, literally the exact same error message. And then let's pass 3 inputs in. Notice that this is an internal check using too many error inputs. I didn't actually code that out. MATLAB does that itself, so it's kind of a nice thing. So we now know that our function requires 2 inputs, and we have a check to make sure that's true. This block of code is running properly. Okay, so let's go ahead and check the next one. So check that neither input is empty. So if x is empty or y is empty, then we want to produce a code. So this would be the empty check. And to be honest with you, we don't need an alpha anymore. So we can delete that alpha because remember that this is going to be 2 vectors. I might go ahead and just copy this and drop it there. So I'm not having to redo that all the time. Okay, so let's produce 2, and we'll put one as empty and the other one is non-empty. At least one input is empty, which is no good. Okay, so both inputs should be non-empty. Inputs must be non-empty. It doesn't really matter what the error message is. We weren't told that, and that's something that you'll develop as you write. What type of error message you want to produce. We're not systematizing these yet because we're kind of slowly building up that functionality. Let's go ahead and check if we did the other one is empty, what would happen? And why don't we check that both empty? This is a logical check. Since we have an inclusive OR, pretty sure it's going to trigger every time, which it does. So we're now sure that that error message is working properly, which was part of my specifications. Remember that we wanted to produce an error message as either is empty. We want to make sure that the number of inputs, I actually didn't put that here, but it's always a good thing to check that the number of inputs that you have matches the number that you expect. All right, so let's keep going down. Let's do the double data one. I'm going to copy this and just overwrite that one there. So we're going to typecast these as non-double data, and we'll do one at a time. So let's first typecast X as a single data class. Talked about that in previous videos. So if I do this, what happens? Let's see. Oh, MATLAB is upset because I haven't actually uncommented this yet. There we go. So let's do that again. Yep. So dcopy. Oh, of course. MATLAB is getting mad because I don't have an alpha. I have an X. So X and Y, not alpha and X. That's part of, yep, there we go. Part of using code is you got to change everything. And one of the really nice thing about error checking is it's a way to kind of make sure that you've changed everything. The other way is, of course, to slow down. But notice that if X is a single, then, of course, we trigger a problem. Let's go ahead and typecast Y as non-double data. So in this case, we'll use integer, maybe 64 bits. That's one of the data classes that we'll talk about later in the class, integer data. Both inputs must be double. And of course, if we had both of them non-double, the error still runs. Let's go ahead and change this to double and this to single. Okay, so now we know that our argument check works, our isEmpty check works, our double check works, which we kind of knew already because we were going to use it, but it's really nice to make sure that it's working again. And now we want to check that both inputs are vectors. We actually don't need this. So let's see here. To check that both inputs are vectors, we're going to basically do a similar check as we did before, right? So we're going to get the size of X. Let's do the same thing. Let's guess the size of Y. So we're going to say that this is the size of Y. Okay. Now, we know that if mx is not equal to 1 and x is not equal to 1, that means that x is not a vector. And we also want to know, one thing that we could do is just do two different if statements, right? We could do this if statement, the first input is not a vector. And then we could do a second error check where my not equal to 1 and ny not equal to 1. But really, we just want to make sure that both are vectors. So if x is not a vector or y is not a vector, in other words, if I did this one, both inputs x and y must be vectors, right? Because this one would trigger if x is not a vector, this one would trigger if y is not a vector. The or is inclusive, so if both of them are true, the whole thing is still true, which means we don't need the scalar error check, but we do need the vector error check. We do want to make sure that if we send stuff that's not vectors in, that we still produce that error. So let's go ahead and just error one of the inputs is not a vector. Okay, so we're not doing typecasting in this case. Okay, so let's go ahead and do a 15 by 2 and a 15 by 1. And let's run it. Okay, so if the first one is not a vector, it triggers. Let's trigger the other one. Let's do a 2 by 15. It doesn't really matter 15. Let's do 10. Okay, what if both are vectors, or not vectors? Yep, still triggers. So in this situation, we see that the vector check that we wanted is working as we expect. All right, so this check is working as expect. All right, so now we're actually going to do the copy. Oh, and guess what? I just figured out copy vector y x into vector y with using size of y as the output size. Okay, so we can actually delete this stuff for now, and then we got to kind of think about what we're doing here. Yeah, we're not doing a scalar multiplication. So if nx equals 1, that means x is a column vector. You know what? I think we need one more error check, to be honest with you, that's different than the one that we did previously. So right now what we've done is we've checked that both are vectors, but we actually need to check that they have the same number of entries. Let's do a little bit of thinking. So we have a vector x, and that vector is size either mx by 1, so this is what we call a column vector, or we have a row version of that. So if x was a row vector, we would say that it's 1 by nx. And then we have a y vector too, right? So the y vector, we say that if it's a column vector, that would be my by 1. And if it's a row vector, that would be 1 by ny. If they're both column vectors, we want to just make sure that that's true. And this would be, of course, under the condition that nx equals ny, and they're both equal to 1. Okay, so over here, if vector y and vector x, so if x is a column vector and y is a row vector, so x is a column vector and y is a row vector, in this case we would need that mx equals ny, and of course nx equals 1, which is equal to my. Okay, so notice over here, if x was a row vector and y was a column vector, we would have that nx must be equal to my, and of course mx was equal to 1, which is equal to ny. And then the final condition, if x is a row vector and y is a row vector, it must be the case that nx equals ny, and of course mx equals 1 equals my. But notice this thing is pretty much identical to this thing, right? This thing right here is pretty much identical to this one, which would mean that we really have one condition, right? Mx equals my and nx equals ny, and that's in either case. And then the other one, of course, is that this right here is identical to that right there. So nx equals my and mx equals ny, since this one and this one are identical, so there's only two. But I want to show you something really interesting. Notice that in any of these situations, one of the vectors is, one of the dimensions is 1. So here, mx by 1 or 1 by nx, one of those has to be 1. And the same thing is true over here. Which means if we thought about the vector x as mx times ny, and the vector y as my times ny, these conditions actually can be combined into a single condition, which is count the number of entries. Well, the number of entries in x is going to be mx times nx. So this is number of entries in x. And that's because one of those will always be equal to 1. Well, what about the number of entries in y? It must be my times ny, right? Because one of those will always be equal to 1. What are we saying when they have the same length? We're saying that the number of entries in x must be identical to the number of entries in y. We don't care whether or not one of them is column and one of them is row, right? This is the same thing as using the length function. Equal length of y. And in fact, this could be the condition that we use. Once we know that it's a vector, we could just say that the length of x equals the length of y. But with vectors, the length is equal to the product of the dimensions because one of the dimensions is 1. So in other words, we could do these two dimensions, or we could just realize that the product of dimensions of x must be identical to the product dimensions of y. Okay, let's go back to our code. So over here, let's check that both inputs are vectors. Let's check that inputs x and y have the same length. So if, and what did we say? We said that if mx times nx was not equal to my times ny, then we produce an error message, which is the input vectors must have the same length or the same number of entries. Okay, so let's go ahead and check that. Let's go back to the copy driver, and we're going to do what we call different. So this is a vector error check. This is going to be different sized vectors error check. Check that both inputs have the same number of entries. Okay, so let's do a 15 by 1 and a 1 by 10, and we'll run it. Check that out. Input vectors must have the same number of entries. Let's do a, I guess we could test all possible combinations, right? Row, column, column, row. So this one's been both row. Let's switch over to column vector. So now let's do 4 by 1. And then we'll do a 10 by 1. All right, so that's working properly. No matter what type of vectors we put in, they must have the same number of entries. If the entries are different, we produce the error vector in every single situation. So we've now done everything that we're supposed to do. We've checked the type, if they're empty, if they're vectors, if they're double, that they have the same number of entries. And now we're going to get down to the actual functionality that we wanted. I jumped the gun earlier. Okay, so let's think about this for a moment. So there's really two options for both vectors. If nx equal 1, then x is a column vector. And then we really have two choices. ny equal to 1 means y is a column vector. And then what are we going to do in that case? For I goes from 1 down to mx, right? Because we're going to be going down the rows in that situation. We want to overwrite the corresponding value of y with the desired value of x, because the idea was to copy x into y, right, with the same dimension. So, all right. If ny is not 1, that means that my is 1. So in this case, y is a row vector. So if x is a column vector, then y is a row vector, and y is a row vector. That means that when we do this copy, we would copy the individual entries of x, which is stored in a column, onto the individual entries of y, which is stored in a row, right? And the number of places that we would go is the number of entries in x. Okay, so I think that's working pretty well. The same can be true. So if nx was equal to 1, then x was a column vector. If that's not true, then mx is 1, which means x is a row vector. And then we have literally this exact same condition inside, right? So this is going to be a copy of itself, basically, except that x will now be a row vector. And if x is a row vector, we're not going to go up to the number of rows. We're going to go up to the number of columns. So x is a row vector, we go across columns, but y is a column vector, we go down rows. Okay, if x is a row vector, we go to the number of columns, we go across the columns of x, and then we store across the columns of y if both are row vectors. And in this case, what we're going to do, remember that we're trying to return the copy of y. So y out, which is the output, is going to be the values of y that we've just overridden. And that's the end of the dcopy. And of course, we're now done error checking. So we've done all the checking that we needed to do. We can now click that out, and we're going to verify input. So we're going to do case 1. X is column vector, y is column vector. Copy a column vector onto a column vector. And I can already tell that I don't really want to reuse have to edit twice, so I'll just recopy case 1. Let's start with an 8x1. We'll do some random, if we're really excited, we could do non-integer values. And let's do integer values. It's easier to see that way, right? So x is some random. Let's do y as a random, same size. So these are different random values. And then what we're going to do is copy x into y with the same size, and now we need to check that the two are similar. So in this case, we're going to put let's compare the original vector to our copy. Okay, so here we have our original vector x, right? And then the output, which is going to be y out. And of course, we could look at the difference between the two of those. And if that difference is 0, we would say that we've done a good job here. The dimensions should be the same, right? 8 by 1. So if we run this thing, okay, check that out. We have now copied x into y. So here's my original x, there's my new y value, and notice that that y out, I did mean y out, is not the same as y, right? Those are different vectors, which means indeed I created a copy of y out of the vector x. Okay, so now we just wanted to test that all 4 cases are true. And indeed, this is really kind of powerful. So the thing that I would do here is run through each one. So case 2, x is a column vector, y is a row vector. Copy a column vector into a row vector. And the one thing that I would change is that these switch. And let's go ahead and change. And of course, if my output is a row vector, but I want to compare, I've got to put a transpose on it, right? Unknown variable m, it's getting upset because I forgot to decomment that. Check that out. Let's go ahead and check y out and x. I did mean x. Notice that y out is a copy of x, but y out is the same size as y. Y was a row vector. That's exactly what I expected. And I'm going to let you viewers at home finish the other 2 cases. It is actually important, I believe. I think it's super useful to check every single line of code, because we're never sure whether or not the code that we produced has errors in it, right? Especially when we're copying and pasting from old code. So in this case, we're going to say this is a row vector and this is a column vector. Go ahead and make those changes. And then the last case would be, let me delete this so that I don't have to deal with it. You all can do that at home following along. The last thing that we're going to check is that case 4, x is a row vector and y is a row vector. And the whole time you're checking that the different conditions that you are imposing work the way that you expect them to. I wanted to give a visual representation of what this function is doing. Let's assume that we start with 2 column vectors, each of which has 4 entries. So the mathematical equation is just we're setting one variable equal to another variable. We have the pseudocode to do this. And then in the function, what we do is we pass our 2 variables inside, x and y, so that gets passed to our function. And then in each iteration of the for loop, we do a bunch of error checking. Eventually we kick into the proper for loop. This would be the first if condition. What we do is the vector y sitting in memory, we overwrite all of those entries with the corresponding entry of x in the loop iteration that aligns with the index. So in the first iteration, we go y1 gets x1. Second iteration, y2 gets changed to x2. Third iteration, y3 gets changed to x3. And then we finish it, y4 would get changed to x4. Notice that we're not defining a new variable. It's literally overwriting the previous value of y with the new value. Once we're done with that, we kick that copy out as y out, same dimensions as the original y. And then that's the return from the function. And I just caught an error. Check this out. This should be, of course, y equals xi, and this is y equals x. This is a copy and paste error. This is not a scalar multiplication function. It's just a copy function. All right, we made it to the end, y'all. We now have a scalar vector multiplication function and a copy function.